Lesson 7.2, we're going to be solving linear equations using the substitution method. Now, let's think of the word substitution. Who can tell me a definition for the word substitution? Zachary, what do you think it means?
It's not the real thing, it's just a placeholder.
Okay, a placeholder, or it would be considered a what for someone? Vincent? A backup or a replacement. Substitute, if I'm missing school, I call in and get a substitute because I need somebody here to replace me. Am I at school when I call a substitute? No, I'm gone, okay? That is what happens when we do substitution. Guess what? We've been using substitution since the first day of school. We did it on the first day of school. I gave you a problem like this, like 2x, and I said solve the problem when x equals 2. So what did I do? I substituted that 2 in for x, and I said 2 times 2 equals 4, right? All I did was substitute. Now, did I leave the x in there? No, because a substitute means it replaces. So I'm not going to keep the x in there because I don't need to. The x equals 2, so I take it out and I plug in that 2. Now, this is what we're going to be doing today, except for it's just one step farther. So what if I were to tell you, instead of that x equaled 2, that it equaled y plus 2? Now, I don't know exactly what x equals. I don't know that x equals 2 or 4 or 5 or whatever the number may be, but I do know that it is equivalent or it is equal to y plus 2. Guess what? The rules of substitution still apply. I can take the x in this equation, or it's an expression, and take it out and plug in y plus 2. Say, okay, hold on, what do you mean? I can do 2, and then what does x equal? Y plus 2. I could plug that in, do distributive property, and get 2y plus 4. Just like that. That's substitution. Even though I don't know exactly what x equals, I can still use substitution. Now, I can't solve this any farther because it's not an equation. It doesn't say like equals 5 where I could go ahead and solve it. But I can plug it in and use substitution. So that's exactly what we're going to be doing today. Because I have a system of equations, which means I have 2 equations. Y'all remember that? So I need to try to find the ordered pair that is a solution. Remember, yesterday we found that ordered pair by graphing. Today we're going to find that ordered pair by substitution. Now here's the main thing about substitution. Does everybody hear this? Because this is important. One of your equations has to say x equals this or y equals this. If one of those variables is not alone and it does not say x equals this, y equals this, we've got to make it say that. Okay, but we're going to get to that in another example. But substitution means I have to know what one of my variables equals. Now, I don't need to know that it equals an exact number, but I need to know what it is equivalent to. Okay? In this problem right here, do I know what one of my variables equals? Yeah. Does it say y equals something? Yep. Do I know exactly what y equals? No. I don't know that y equals like 5 or 10 or whatever it may be. But I do know that it is equivalent to x minus 4. So this is what I'm going to do. I'm going to use substitution because looky here. They gave me another equation, right? Does that other equation have a y in it? Yeah. So can I substitute x minus 4 in for that y? Yep, I sure can. So what I'm going to do is I'm going to write 4x plus, instead of y, I'm going to write x minus 4 equals 26. So all I did was I took the exact equation that they gave me in the second part, and instead of writing a y, I wrote x minus 4. Now let me ask you a question. What's the only variable that I have now? X. So guess what? I can solve for x. Anytime you have 2 variables in the problem, I can't solve for an exact answer. I'll never get an exact answer. I have to only have one. So that's why we replace it. That's the whole point. I'm not doing it just for fun, okay? We've got to replace that y and make it say x minus 4. So now I can combine like terms and I can solve. So now let's combine like terms. What are my like terms? 4x and x, which technically there's a what in front of it? A 1. So let's add those together. 4x plus 1x is 5x minus 4 equals 26. Now what do I do? Add 4. 5x equals what? 30. Then I divide by 5. And what does x equal? 6. Now, my answer is always going to be a what? Ordered pair. So do I know my full answer right now? No. I know the x, but now I've got to find the y. Well, actually, now that I know x, it's going to be really simple. Because look what I can do. I can go back up to this equation where it says y equals x minus 4. And can I substitute in a 6 now for the x? Yeah. So we're going to say y equals 6 minus 4. Well, what's 6 minus 4? 2. So y equals 2. There's the ordered pair that's a solution. Guess what? If I were to graph these equations, I would get the exact same answer. Here's my thing. When you find out what x equals, you can plug that back into any of the equations for x, okay? You can plug that back into any of the equations. It does not matter which one. You'll still always find y. So the next example. Now, I don't have a problem that says y equals this or x equals this. So I'm going to have to come up with that. And there's several different ways that you can do it. Actually, we can get any one of these 4 variables by itself and solve. It does not matter which one you do. If you want to do the x, great, go for it. If you want to get that y by itself, great, you go for it. This x or that y, same exact thing. Any one of those variables that you isolate, we will all still get the same answer. However, even though you can use any one of those 4, there's usually one out of the 4 that's less work than the other 3. So on this example, I'm going to help you locate the easiest one. The easiest one to isolate is usually the variable that you don't see anything in front of. Now, technically, we know that there would be a 1 there, but we don't see it. So it makes it easier to isolate. So which one of these variables would be the easiest? X in the first equation. Because what would I need to do to get it alone? Subtract 3y. And I would get x equals negative 3y minus 11. Now do I know what x equals? Yep. So I can use substitution. Okay. I would plug it into the second equation for x. Now the problem that we did before this, the y was by itself. That's okay. Remember, it does not matter which variable you get alone. Now you say, wait a second, but I want to get this y by itself. Okay, go for it. We would subtract 2x on both sides, and we would get negative 5y equals negative 2x plus 33. Then I would need to divide by negative 5. And I would get y equals 2/5 x minus 6 and 3/5. Guess what? If I use that, I'll still get the same exact answer as I would if I used x equals negative 3y minus 11. But you think it might be a little more difficult to use this problem? Yeah, it's going to be. Okay? So, again, you can isolate whichever variable you want. It'll work no matter what. But there's some that you can use a little less work to get all alone. Okay, now we're not going to keep solving this because I'm just, in this example, trying to help you recognize which variable would be easiest. So if I wanted to keep going, what I would do here is I would take this negative 3y minus 11 and I would plug it in for the x in that equation. And I would use substitution, and I would get what y equals. Then I'd plug that back in and get what x equals. Okay? Now, let's look at the next equation. Which one of these variables do you think might be the easiest? The negative y. Now, technically, what number is in front of that y? Negative 1. So I will need to subtract 3x, but then once I subtract 3x, I'm not done. Because what's the number that's still in front of y? Negative 1. So then I need to divide everything by negative 1, which really all that means is I change my sign, so positive 3x plus 9. So technically, yes, to get any one of these variables alone, it's going to be 2 steps. But it's usually always easier to divide by a 1 than it is by any other number. So that's why we chose that one. So now if I wanted to keep working, I would take 3x plus 9 and substitute it into the next equation for 4 and solve and get what x equals and then solve and get what y equals. But I don't want to do that yet. We are going to do that in the next lesson. But I just wanted you to see how you can identify which variable would be easiest to get all alone. So in the next example, what I'm going to do is I'm going to put that all into practice. Okay? Do I have an equation that says x equals this or y equals this? No. So that means I cannot do substitution just yet. I need to get one of these variables all alone. So it will say x equals this or y equals this. Cole, which variable do you think would be the easiest to isolate?
For me, x.
Okay, for you, x. So you want to get the x all alone here. So what would you need to do to get the x all alone?
Substitute 2x with y. Or y with 2.
We can't do that. What I need to do is I need to get one of the variables by itself. So that means I need to get the y by itself. So I need to subtract 3x, and I get y equals negative 3x plus 5. So that's how I would isolate one variable. If you wanted to isolate the x, you could do that, but what you're going to end up with is you're going to end up with some fractions, and that might not be as easy to work with as this problem that we have here. So it wouldn't be wrong to isolate the x, but it was probably going to be a little more work. So let's try to get the y by itself. So we did that. Now, time out. Before I go plugging things in, I need to look at this second equation. What is the number in front of y? Negative 1. Let's write that because it makes a difference. What I'm going to do now is I'm going to say, okay, I know what y equals, and it equals negative 3x plus 5. So I can take this, and I can substitute it in for the y in this equation. So I write 2x minus 1. Then what am I plugging in for y?
Negative 3x plus 5.
Negative 3x plus 5 equals 10. What am I going to do with that 1? Zachary? Distribute it. If you would not write the 1 in front of it, you might just think that, oh, the double negative, so 3x becomes positive. Yes, that is going to happen, but what's going to happen to the 5? It's going to become negative. And if you don't distribute that negative 1, you might be confused. Now what would I do?
You would add 5.
Add 5. What else could I do?
Add 2x and 3x.
Which is 5x equals 15. Then I need to divide by 5, and x equals 3. Now what do I do? Y equals negative 3 times 3 plus 5. All I need to do now that I know what x equals, I just plug it in. Y equals negative 9 plus 5. Y equals what? Negative 4. So my answer is 3, negative 4. Okay? Okay, let's do the next example. Do I have a variable already by itself?
Yes.
Well, there's no number in front of it, but do one of my equations say x equals this or y equals this? No. So what do I need to do right off the bat?
You need to get it alone.
Okay, which one of these variables do you want to get alone? X. So that means I need to x equals 4y minus 1. Now do I know what a variable equals? So what am I going to do? Plug the 4y minus 1 in for x in the first equation. So I'm going to say 2 times 4y minus 1 plus 2y equals 3. What would I do now? 2y, or 2 times 4y is 8y. 2 times negative 1 is plus 2y equals 3.
Add 2.
Okay, I can add 2. What else can I do? Combine like terms. 8y and 2y is 10y. 3 plus 2 is?
5.
What am I going to do now?
Divide a 10
What does y equal?
1/2.
1/2. You say, oh, a fraction. That's okay. We can get a fraction. What am I going to do now? How do I find x?
And go back to the where it says x equals 4y minus 1, and then you plug in half.
Perfect. Go back to 4y minus 1 and plug in 1/2 for y. Could I have plugged this in for any of the equations and y? Yeah, it would work. What's 4 times 1/2? 2. 2 minus 1 is 1. So my ordered pair is 1, 1/2, and that is your answer. So the last example that we're going to do, they want us to do the exact same thing with substitution, but look what they have done for us on this example. Do we know what one of the variables equals? Yeah. Now, I don't know exactly what it equals, but I know that x equals 2y. So I don't have to get anything alone. It already is alone. What am I going to plug 2y in for?
X.
The x in the other equation. So we're going to say 2 times 2y plus 6 equals 15. What's 2 times 2y?
4y.
4y plus 6y equals 15. What's 4y plus 6y? 10y equals 15. Then what do I do? What does y equal? 1 1/2 or 3/2. I'm going to leave mine as an improper fraction just because it's going to be easier to plug in that way. When if I were to have to graph this ordered pair, I would make it 1 1/2 because that's easier to find on the graph. Okay? So now I need to plug this in for what?
For the x equals 2y.
And what variable am I plugging it in for the x equals 2y? The y. So 2 times 2/2. Now, y'all remember in that one lesson where we learned anytime we multiply a fraction by the same number that's in the denominator, what's our answer? The numerator. So what does x equal? 3. And that would be my answer when I use substitution. And that's how we use substitution to solve systems of linear equations.